Welcome to Brain Vision.
A circle or in an arc of a circle, the force is always perpendicular to the tangential velocity and is always towards the center of the circle. And the value of force is given by m so mv square over r, where r is the radius of this semicircle. Now, since we have a magnetic field over here, so this force F is the caused by the magnetic field, or this force is the magnetic force, which is given by charge times velocity cross the magnetic field vector. Now, the direction of this force is then given by the right hand rule, and so where phi is the angle between velocity and the magnetic field. So here phi is 0 because magnetic field is uh, outwards from the screen and velocity is on the plane. So phi is 90 degrees. So this is equal to Q times V times B. Now, going with the right hand rule, we see that uh, the velocity, the force, if the charge is positive, the force will be in this direction, and if the charge is negative, the force will be in this direction, which is same as the centripetal force over here. Now, since these two forces are the same, so we confirm that this charge Q should be negative. So let's write this down. So this is actually Q should be negative. Now we can combine these two equations, and since we are just concerned with the magnitude of force now, because we already know the direction, so we'll say mv square over r is equal to q mod times v over b. So here we found that q is negative, so basically q should be equal to negative times 3 times 1.6 times 10 to the power minus 19 coulombs from here. So the mod of q will just have the positive part. So we solve for v now. So v will then be equal to q mod times b times small r over the mass. And the mass is given to be 12 times the mass of a proton, and we know the mass of proton, which is, let's write this, and mass of proton is 1.67 times 10 to the power minus 27 kgs. So we use this mass over here and the rest of the values and solve for v, and we get this value to be 2.84 times 10 to the power 6 meter per second. So this is the speed of the particle. Now this is for part 1, and now for part 2 we have to basically compare the gravitational force with the magnetic force here. So let's find the magnetic force first, just the magnitude. So this is equal to basically Q times V times B. So that is equal to, so we know q, we use the velocity that we calculated here, and b is already given. So this is equal to 3.41 times 10 to the power minus 13 Newton. Now we find the gravitational force, which is mass times gravity. So mass is basically 12 times the mass of proton, and gravity is 9.8 meter per second square. And we find this to be 1.96 times 10 to the power minus 25 Newton. Now, if you compare these two values, we see that the magnetic force is much larger than the weight of the particle or the gravitational force. So, it will be a very good approximation to neglect gravity here. Now, for the third part, we can just solve it here. So for the third part, the magnetic force, as you can see here, is always perpendicular to the path, and therefore it does no work, because work is work is basically given by F dot ds and integration. So where, so this will be equal to then F times ds sine, let's say theta, where theta is the angle between force and the displacement. Now we see that here the particle is moving along this direction, and force is always perpendicular to the displacement. That means work is 0, and therefore the particles move with constant speed.